Hello, Mr. Aaron, Mr. Ryan, are you right?
Yeah.
So last lesson we talked about using one stroke to draw the shapes. Is it possible to draw a shape using one stroke? For example, given this, can we draw this using one stroke?
Yeah.
How can we find it out?
By checking how much ways can it check how much lines is connected to it, the point, and then if all of them are even, two of them are odd and the rest are even. No, if they're two odds or no odds, then you can do it with one stroke. Otherwise, you can't.
We need to count the number of the vertex which are odd degrees, right? So if there are two odds or if there are no odds, we can finish drawing using one stroke. If it's two odd, if there are only two odds, then we can start with one of them and finish the other one, right? Yes?
Mm-hmm.
If there are no odds, we can start at any vertex and then finish the drawing and come back to that. Am I right? For example, a simple example is this rectangle. We can start from here, or we can start from here, or we always come back to the same vertex. Degree of the vertex is defined as the number of edges connecting to it. For example, like rectangle again, right? So the vertex, the degree of each vertex is 2 because there are two edges connecting to it, okay? Last lesson we talked about this one problem that we're going to talk about today. The number of the odd degree vertex is always even, okay? The number of the odd degree vertex is even. Okay, let me write the conclusion here, right? The number of odd degree vertex is even. Okay?
The number of
The number of the, yes, okay. The odd degree vertex is even.
That's not vertex, that's vertices. That's vertices.
Okay, it doesn't matter. Plural, singular, it doesn't matter as long as you
Anyway,
understand.
the number of odd degrees are even.
The number is even.
Or odd degrees are
I'm talking about the number. For example, like this one. This is the simple graph, right? Unweighted graph. The degree.
Anyway, if it is even, then you need use vertex. If it's are even, it's vertices.
Okay, it's not important. So let's
It
look
is
at this
important.
unweighted.
It is.
Okay, vertex. Okay, yeah, happy?
There's a big space.
That's fine. Okay, so consider this unweighted graph. Right, unweighted graph. This is a vertex, this is the edges. So we talk about this graph is a collection of vertex and edges, right? These are the vertex, these are the edges. Okay, so what's the degree of this vertex? How many edges connected to it?
1,
Yeah, so the degree is 1. This is 1, this is 1. What's the degree of this?
3,
3. Okay, so how many
4.
I didn't even finish the question. Okay, so how many edges? 3, yeah, 3 edges. Okay, so you're right. Yeah, I was going to ask how many
There's
odd
2
degree vertex. So there are 4,
How
right?
does the odd degrees vertex make sense? Now I'm talking about the odd degrees vertex. What does that even mean?
Okay, so do you understand what I meant
No,
here?
what I'm talking about the odd degrees vertex.
Okay, so can you rephrase it?
That doesn't really make any sense.
Okay, so what I'm talking about is here, right? Here, right? This vertex, the degree is 1, it's odd number. This vertex, degree 1 is odd number, also odd number. This
I'm
vertex,
not talking about that.
I know, this is what I meant, but how do you rephrase this sentence given
Well,
that?
what do you mean?
The number of vertex which has odd degrees, which has odd degree is even. Okay? Look, the number of vertex here. These are 4 vertex which are all having these odd degrees. Okay? So the number, how many? 1, 2, 3, 4. 4 are
Number-
even. Make sense now?
The number of the vertices which have odd degrees is even.
Perfect. Okay. The number of the of the vertices.
Is it
Which, well, sorry, can you tell me again? The number of vertices
which have all degrees?
is even. Perfect, yes. Thank you. Okay? So we want to prove that, right? So this is the conclusion. We want to prove that. So how do we prove? We need to start with this very obvious fact is that the sum of all degree vertex, is 2 times of the number of edges. Right? We talk about that. For example, the sum of the all degree, 1 plus 3 plus 1 plus 1, right? 1 plus 3 plus 1 plus 1, right? Yeah?
6.
6. How many edges?
3.
Equals 2 times 3. That's it. Let's look at another example.
Can I draw an example?
Okay, let me finish this, right? What's the degree? 2, 2, 2, 2, right? So 2 plus 2 plus 2 plus 2 equals how many edges? 4 edges times 2. Alright? Okay, can you draw an example just to double check?
Okay.
Okay, so is this just one finger point?
1.
Okay.
1.
Okay, let's double check. Okay, let's double check. Look, degree this is 1, 2, 2, 2, 1, 2, 3. 3, 1, 2, 3, 4. 4, right? 2 plus 2 plus 3 plus 4 plus 2 plus 1. What's this number?
14, I think. 14, yes.
14, okay? 14 equals how many edges? 1, 2, 3, 4, 5, 6, 7. 7 times 2. Always the number of edges times 2. We talk about how to prove this. Look, consider this simple example. 1 edge contributes to 2. 1 edge contributes to 2 degrees. Am I right? Look, what happened to 1 edge? If it's the edge, it must be connected to 2 vertices. Am I right? It's connected to 2 vertices. It contributes 2 to the degrees, right?
Yeah.
Okay. Now we want to prove this. Okay. So how do we prove? We base on this, right? We base on this. So this, the sum of the degree, right? The sum we write it this way. The sum, yeah. Sum. This is the symbol of the sum. Sum of all the degree, right? Sum of all degree. I, if there are n vertex, for example, right? If I equals 0, I equals 1, right? To n degree vertex I. Okay, this is the even number, right? And let's assume the first R vertex has the even degree. Okay, so it can be rewritten as sum I equals 1 to R degree Vi. The first R even degree. Okay, degrees. And the rest are odd degree, right? So plus, right? Because look, there are n vertex, and here the first R are even. Here this bit is even degree. The rest is from I equals R plus 1 to n. The sum of all the degree Vi, the same, right? Okay, so look, the sum of all degree equals to the sum of those vertex which are even degree plus the sum of those vertex which are odd degree. Okay, this is even number, right? The left part is even number. This bit is even number because each vertex has even degree, so it's a even number. Okay, so we are saying that dvi, this is the odd number, right? Odd number. Each vertex has the odd degree here. Okay, so look, even number equals even number plus, the number of this is n apostrophe is equals apostrophe is the number. Okay. The number, okay? The number of vertex, this is n apostrophe. Apostrophe times times an odd number here. Okay, so what do we get? Look, the even number equals an even number plus an odd number times n apostrophe. So is this an even number or odd number? Is this an even number or odd number?
Apostrophe. Even.
Yes, it's even. It can't be odd, right?
Yeah.
Why? Because look, this is even number equals even number plus this one. So this must be an even number. And we already know this is odd number because each one, for the remaining n minus r vertex, these are the odd degree vertex. And it must be multiplied by an odd number to make it even number. Am I right? Bless you. Okay.
Thank you.
Give an example. Okay. So this must be even number, right? So n apostrophe times
Trap.
7. Okay. What I'm saying is, okay, so this is an even number.
Yes.
So what's this number? Is this a even number or odd number? This whole thing is an even number. So this thing is an even number or odd number?
Even.
Yes, even, because it's odd. It doesn't make sense, right? 1, 3, 5. It's multiplied by 7. It's still an odd number. It has to be even number to make this an even number. Okay, so let's repeat. This is the thing today. Okay, we want to prove the number of the vertices which have odd degree is even. The left part is even number because we know the sum of all degrees is 2 times of edges. Right? So this is an even number. So left part is even number. So the sum of the degrees of all vertex can be divided into 2 parts. The sum of those vertices which are even degree. Obviously, this is an even number, right? Yeah, because no matter how many vertices times an even number, it's an even number, right? So 2 numbers multiply together. If one of them is even number, the answer is even number. Am I right? Yeah? 2 times something, is it an even number?
Yeah.
100 times something, is it an even number?
Yeah.
Yeah, simple. Okay, so this bit is even number. Then the remaining, this bit is also an even number because the even number minus an even number is an even number. So this bit is an even number. Okay? So even number. So what's this bit? This bit is the sum of the degree for those vertices which has the odd degree, right? So because they are all odd degree, so this bit is odd. So it has to be multiplied by an even number, right? So we prove the number of vertices which have odd degree is even number. Make sense?
Mm-hmm.
Any questions so far?
No.
What have you learned today?
The numbers are even.
What numbers are even?
The numbers are even.
Everett, can you read it out, please? Come on.
Number of the vertices which have all numbers are even.
How do we prove it?
That's even, that's even, that's even.
And that's even. Yeah, proof. Yeah. Mathematically proof. Okay? Okay, that's it for today. Bye-bye.
Bye.
Bye-bye.